So on page 19, we're going to take a look at some stuff today about quadratic functions. So you guys have seen that word quadratic a whole bunch already. Just to save a little bit of time, because we're starting later than I thought we would today, we're going to skip just a couple of the ones in here. So we're going to cross off number 1 and jump down here to number 2. Can we go to Connor for number 2? Okay, so I'm just kind of defining the word degree. It's the highest power. So degree is 2 for every quadratic. We'll go to Hazen for 3. Okay, so first I'm using the word parabola. Do you guys know, do we know that? That if it's an x squared equation, then the graph is called a parabola? Does the graph look like this? Can you guys with your hands or arms make a, like, what does it look like, the graph of every parabola? Yeah, so it's some kind of a curvy thing, like a happy face or a sad face. So the question is, what does this one look like? Maybe some of you guys already know whether it's going to be a happy or a sad, but still there's a whole lot of other stuff to know about it. Can you guys tell if it's a happy or a sad? A bunch of people say happy. Why? Yeah, it's a positive x squared. We're going to see that on the next page, but some of us know that already. So, okay, it's something like that. But do you guys agree there's a whole lot of different happy parabolas? Like it could have been that, or it could be really tall and thin, or it could be really, really wide, something like that. And aren't there a whole bunch more that I haven't drawn in? Like, couldn't it be out here somewhere? Like, there's nothing saying that the bottom point has to be tied to the origin. So even though we know it's happy, we still have to figure out exactly where it is. So let's see if we can graph this thing by plotting a few special points. So one special point that we're going to graph is going to be the Y-intercept. And if you're at the Y-intercept, what can you say is definitely true? X is 0. Yes? At every point on the y-axis, x is equal to 0. So to find the y-intercept, we just let x equal 0. And if we do that, let's see. So I'll write it like this. F of 0 equals 0 squared minus 2 times 0 minus 3 is negative 3. So that means that the y-intercept has what coordinates? 0, negative 3. Super. We just found a point. It's right down there. So finding the y-intercept is pretty straightforward. Plug in x equals 0. All right, so then can I say if it's happy that it then necessarily looks something like that? Maybe it's wider or maybe it's thinner, but is that true? All right, so you're using a word we haven't defined yet, vertex. What's the vertex?
Point where the parabola changes direction.
Yeah, point where the parabola changes direction. In this case, it's the bottom point, right? If it were a sad parabola, then we would say that the vertex is this point up here at the top. But where it changes direction is a good definition. Are you guys confident that it changes direction at negative 3? Couldn't it just decide to go right on through negative 3 and then change direction somewhere else? Yeah, so like, that first point isn't necessarily the vertex. So it feels like we need to know where that vertex is. The bottom of the parabola is, it's important, it's the bottom, something changes there. On the next page, we're going to talk about a way to find the vertex, a really, really easy formula that we'll look at. But for right now, we don't have it. So how about we take a look at x-intercepts? What should we do to find the x-intercepts? We'll let y equals 0, right? If you're on the x-axis, y is definitely 0. Okay, I don't see any y's in my function here, so what's 0? F of x, right? That's the y. So the whole left-hand side is 0. So let's see, 0 equals x squared minus 2x minus 3. That's letting the whole thing equal 0. And now all of a sudden we have a quadratic equation to solve. And Taylor had said quadratic formula. It always works. There's also completing the square. Do you guys remember we talked about that briefly one day? We agreed that we would never do it again. But then if we're lucky, what's the easiest way to solve? Is factoring. Now it doesn't necessarily factor, but I don't know about you, I'm feeling lucky. So can you guys factor? Okay, what's the factorization? -3 + 1. Everybody okay with that? Any questions on getting that? Okay, and then we split it right down the middle. Either x - 3 is 0 or x + 1 is 0. So what are my two x's? X is 3, x is -1. Okay, so 3 and -1. 3 and -1 is here. Is that what we just figured out? What were we finding? The x-intercepts? That's not on the x-axis. I plotted 3 and -1. There's two x-intercepts. These are not the same point. In fact, they really don't have much to do with each other at all. So we know that x is 3. How much is y? 0. That's what we did first. We know x is -1. Y is 0. Those are my two x-intercepts. So when you're ready, plot those 2 points. Are we still thinking maybe this this point down here is the bottom point of the parabola? It's like that, and then I don't think so, right? I mean, like there's a symmetry happening here. Like that can't be the bottom. But if you buy into the symmetry, yeah, take a look at that line segment right there. If we buy into the symmetry of this parabola, this curvy happy face thing, then the bottom point has to be right in the middle of those two x-intercepts. So I know my x-intercepts are 3 and -1. So if I take those guys and I average them, 3 plus -1 divided by 2, that's our average. What does that equal to? 1. That's where the vertex is. At x equals 1. So it's right here. So the vertex is someplace, I mean, I'll ballpark it and say it's right around there. I don't know it's exactly there. It's someplace down there. How could I find out exactly where it is? You have x equals 1, right? And you have the function right up here. You find f of 1, you'll figure out exactly where that point is. So go ahead and plug 1 into that thing. Do we get -4? Everyone agree? Here's a random thing that's true about the bottom thing. I only learned this like 3-4 months ago. My whole life knowing about parabolas, and I didn't know this one thing. So now I'm going to save you guys that like strain that I lived through. If you know that the vertex, the bottom, is at x equals 1, what you can do to find this, pretend you don't know this, is you take that number right there and you subtract that number. -3 minus 1 squared. How much is it? It's -4. Take your -3, the last number, subtract the first thing. Turns out you don't have to look at this piece at all. Last guy minus the first guy. Crazy, isn't it? You guys are going to sleep so much better tonight knowing it's a little shortcut. Okay, let's get rid of that. Not so important for us. But what is important is that we just found the bottom point. Put it here, f of 1 we just decided is -4. So that means that the bottom, which we're going to call the vertex on the next page, is at 1, -4. Okay, how many points do we have on our parabola at this moment? At 4. I'm going to ask for one more. It's a real easy one. It's at x equals 2. Can you guys find when x is equal to 2? Where is it? Yeah, a few votes for right there, that point. Because of that symmetry thing, right? It's perfectly symmetric about this middle line. So without any work, you just kind of copy this green dot and put it over there. And that's enough. That's 5 points. It's plenty. Let's draw our parabola up forever on both sides. Questions on that? Okay, let's take a step back. Was finding the y-intercept easy or hard? Easy. Plug in x equals 0, it's arithmetic. Is finding the x-intercept easy or hard compared to the y-intercept? It's harder, because to find the x-intercept we had to solve an equation. It wasn't arithmetic, it was algebra. Now this equation wasn't too terrible, the one in blue right on the top right, because it factored. But if it didn't factor, what would you have to do? Quadratic formula, and now it's getting quite sticky. And well, if we want that, just type the thing in and look at it, build a picture anyway. And then once we have the two x-intercepts, we use this idea of symmetry to say, okay, then if the x-intercepts are these 2 points, then I better go right in the middle, and that's where I'll find my vertex. So that wasn't too bad. Do you guys see a problem? Could I draw another parabola where the vertex will not be right in the middle of the x-intercepts? You guys understand what I'm saying? Like we found these x-intercepts, and from that, we went right to the middle, and we said, oh, the vertex must be down there somewhere. Can you imagine a parabola, a graph, where the vertex is not right below the x-intercepts? Like right in the middle of the x-intercepts? Michael? If we shift it, which way? Like left? Oh, tilted. Oh, tilted. Oh, very good. You guys buy that? If you have a tilted parabola, and the vertex maybe is here, is definitely not halfway between. Very good. We're going to avoid this problem by not studying tilted parabolas at all. But we are going to study more parabolas that are straight up and down, just like this one.
In what class do you tilted parabolas?
Probably pre-calc. X class. What if the parabola looked like this? Does it have a vertex? A bottom point? Right there. Is that vertex right in the middle of the x-intercepts? I don't think so. Why no? There's no x-intercepts, right?
Find another y value.
Well, we would need to do some work. Do you guys see that this whole find the x-intercepts and go to the middle, it's not foolproof. If your parabola has no x-intercepts, then we're stuck. It doesn't help us to find that vertex. By the way, what would it have looked like? Over here, we solved this equation, and we factored it, and we got our 2 answers. What would it look like if it had no x-intercepts? Because I feel like we could solve any equation you give us over here. What kind of an equation would have no x-intercepts? But every time we're going to set y equals 0. I mean, like, you know, I could give you another one, like x squared. Yeah.
Or a sad parabola.
Right, but I'm after what's it going to look like? I mean, I'm giving you an equation, right? You could solve that equation. Does it factor? I don't think so. So what do we use? Quadratic formula. What's going to happen when you use the quadratic formula? Can you get a negative in there? If you get a negative inside of the radical, we haven't studied it yet, but what are those numbers called? Imaginaries. They have the i's in them. We will look at them together later this semester. But if you get some imaginary numbers here, what does that mean? Well, it means it has no x-intercepts. It means it's something like that. So that's a preview. All that is to say is that we need another method. Finding the x-intercepts and then going to the middle is not going to always get us the vertex. Okay, turns out there's a really, really simple formula that tells you where the vertex is. Take a look at the equation we started with right up here. You guys are familiar with this form of the like a quadratic because it's how you use the quadratic formula, right? A, B, and C. This is on the next page, but I'll just write it here. The x-coordinate of the vertex is always at negative b divided by 2a. The x-coordinate of the vertex is always at negative b divided by 2a. Let's try it for this example. How much is negative b? It's positive 2. Do we see it? Because b itself is already negative 2. So we do positive 2 divided by 2 times, how much is a? Is 1. What is this equal to? 1. So plugging into that formula tells you the x-coordinate of the vertex is 1. Was it? Was the x-coordinate of the vertex 1? Yes, it was. Was that little formula easier or harder than solving this quadratic equation by factoring and then averaging your two numbers? A whole lot easier. So if you ask me to find a vertex, never in a million years am I doing this x-intercept thing. I'm using my nifty little vertex formula. The nice thing is it's not just another thing for you to memorize. I don't think. Do you guys remember the full-on quadratic formula? Negative b plus minus 2a. Okay, raise your hand if you think you had that whole thing in your head. Okay, most of us. Fine. Do you see this negative b over 2a? It's there. It's just part of it. Just ignore the stuff after the plus minus. Okay, so let's see, again, kind of skipping around a little bit. Let's jump to, what are we jumping to? Let's jump to the bottom of page 20. And we're going to try number 9. Okay, we'll go to Sam. Did you read number 9? Okay, so the only thing that we haven't seen today is that standard form business, and we'll look at that at the end of this problem. But let's see if we can find some other stuff. We'll begin with the vertex, which, by the way, is the thing we ended with on the other one. But now that we have our nifty formula, we can start here. So again, what's the formula? Negative b over 2a. I'm going to insist that you guys put something in the front. It's not just a negative b over 2a floating. What is it? It's the x. You got to know, because the vertex has two pieces. It's a point. So let's plug into that negative b over 2a. Check in with your neighbor. Make sure everybody knows how to plug into that formula. Check with your neighbor out loud. Do we get 3? Is 3 the vertex? 3 is only the x of the vertex. So how do you find the y? People get really confused. They forget how to find the y, but it's easy, right? You've got a formula there, that f of x formula. It tells you everything there is to know. So plug that 3 in. So we're looking for f of 3 here. Did we get 4? Did anybody use my nifty little thing? Last thing minus the first thing? Okay, so that means that our vertex is now found. It is at what point? 3, 4. If I ask you for the vertex on a quiz or a test and you say 3, I will say minus something. 3 is not the vertex, it's only part of it. Okay, all right, we've got the vertex. Let's see if we can find the Y-intercept next. That's the easier one. So to find the Y-intercept, what do we do? Let x equal 0. F of 0 is 49, agree? Are we starting to see the shortcut to finding the Y-intercept? It's always C. It's always the number sitting there at the end. Makes sense, because if you let x equal 0, then everything with x just disappears. 49 is the only thing left. Was that true on the first example? What was the Y-intercept of this one? -3, that number is sitting right there at the end. We're going to see that come in again too, but I'm glad some people are seeing the pattern. Okay, so that means that the Y-intercept, again, it's a point, it has 2 numbers. Make sure you pick the right one to be 0. Which one is 0? X, 0 and 49. Okay, to find the X-intercept, what do? We let y equal 0. So what does that mean in this case? It means 0 equals 5x squared minus 30x plus 49. I'm not even convinced that one factors. Anybody find a factoring for it? Yeah, I suspect it probably doesn't. What'd you say, Eric? Yeah. All right, so if it doesn't factor, we're doing quadratic formula, also known as